Howdy, 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 howdy. This is a video that covers spectrum and atomic emissions. A spectrum is a series of colors produced when sunlight is separated by a diffraction gradient. We have the colors of the rainbow: red, orange, yellow, green, blue, indigo, violet. So that would be Roy G. Biv. Some of you have heard that before. But we want you to know a little bit more about the color spectrum, and that would be that red has the longest wavelength and the lowest frequency. So if I'm drawing a picture of red light, its wavelength is going to be long and slow. We have a low frequency, but a very large wavelength. Now, violet, on the other hand, and blue would be the shortest wavelength and the highest frequency, which also means the highest energy. Atomic emission spectrum are series of lines produced by passing light through a diffraction gradient, which splits the light into all the colors of the rainbow. These spectra can be used in what we call element identification. This is how we identify what elements are in stars in outer space. So if we take light and we pass it through a prism, what we get on top with white light is we get all the colors of the rainbow: red, orange, yellow, green, blue, indigo, and violet. But let's say we pass through an element of just hydrogen, and we split the light that we get from exciting hydrogen. Well, what you see over here is that we only get a certain amount of colors. And if you look down here at the bottom, you'll see the bands of colors at different frequencies. The NM stands for nanometer. And this is unique to hydrogen. It's almost like another ID code. So there are lots of different atomic emission spectrums for all kinds of different elements. And what we find is that the sun produces white light, and you'll see all the different colors of the rainbow up here. Hydrogen, we saw, only has a certain amount of bands. Helium has a few different ones here, a little bit more. And then we get to mercury, and we have a little bit of green in here, some smaller bands of red, but brighter bands of yellow and green. Uranium is a large element, element 92, and it's got a bunch of colors as well. Perhaps that's because it has way more electrons than, say, hydrogen does.